Hi folks, welcome to the second little video on circles. This is lesson 6 and we're going to be looking today at how to find the equation of a tangent. If we think back to tangents from last lesson, we looked at how to show that a line was a tangent, and we saw that they only have one point of contact with the circle, but today we're going to actually be trying to find the equation of this red line. It is just a line though, and so to describe any straight line mathematically, we just need to know the gradient of the line. We need to know a point that lies on the line, and that point is going to be, in all cases for this, the point of contact with the circle. Most commonly you're going to be given that point, and so we're just going to be using the point that we're given, and the bulk of the question is done trying to find the gradient of the tangent itself. And once we've got those two things, it's just the norm of substituting into our straight line equation. So not the equation of the circle, because that's not what we're describing. So substituting into the equation of a straight line. Okay. Now, if we just go over to the diagram and have a little look at it, we are going to be trying to find the gradient of the red line. And I'm going to draw another line on there just now. And if I draw on this line here, a line that goes from the centre to the point of contact, then we would describe this line that I've just drawn as the radius. And what happens when we draw a radius to the point of contact, we create something that's going to be useful. We create a right angle, And so what we know is that the gradient of the red line, is perpendicular to the gradient of the green line. So that means that we've got essentially that m1 times m2 equals -1, and we can use this idea of perpendicular gradients to identify the gradient of the red line if we can find the gradient of the green line. We should be able to find the gradient of the green line because we can use the centre and the point of contact to find the gradient of that green line. So we're going to have to find the gradient of the green line first, and that's going to allow us to find the gradient of our tangent. We're going to know our point of contact, and then we can find its equation. Okay, so we're going to look at two examples, just going through this process, and then again there's some practice at the end of the video for you guys to go away and try. Okay, example 1. Find the equation of the tangent to this circle at the point 7, 5. So again, I'm going to use my common straight line structure, of m point equation. The equation, like I just mentioned, is our straight line equation, not our circle equation. And in order to use this equation right here, we're going to need to know a point that lies on the line, and we can see the point up here. So I'm just going to stick that in straight away. So we've got the point 7, 5. And then we're going to have to try and find the gradient of our line. Now, a wee sketch might be helpful, so let me try and just kind of sketch this out. So here's our circle, here's a centre. I don't know that point at the moment, but I'm going to be able to work it out hopefully very shortly. I know a point of contact, and again, my sketch might be nonsense, but it's going to help us with the thought process. So there's the point 7, 5 that we know, and this point lies on the circumference, not within, not out with, and it's not the centre, it's a point on the circumference of the circle. And what we're going to go ahead and do is we're going to go and find the gradient of this radius. I can't do that just yet because I don't know the centre, so I'm going to go ahead and try and find the coordinates of the centre, and the way that I'm going to do that is by using the circle equation. Okay, we know that we can extract the centre from there. We also know we can extract the radius from that, but the actual length of the radius isn't important to this question. And then once we've got our gradient, we can of course find the equation of our tangent that may or may not look exactly like that. Okay, so we're going to take our circle equation up here, and remember when we're looking for the centre, we're actually only focusing in on these two bits here. We're going to start off just by writing down what 2f and 2g are worth. So 2g is equal to, and don't forget the sign, -6, which means that g is equal to -3. And then we've got that 2f is equal to -4, and therefore f is equal to -2. You are given the general equation of a circle on your formula sheet, so you'll be able to find the generalised version of that there, and it's going to have your f's and g's marked on in the right places, and then it also tells you once you've found f and g how to get the centre, and it'll give you something that looks like this. The centre is negative g, negative f. So we're going to go ahead, and all we're doing is we're just going to sign change these up as we input them. So we've got that g is 3 and f is 2. So our circle has a centre at the point 3, 2. We can now go ahead and find the gradient. And what I'm actually going to do, I'm going to take this bit of working and I'm going to do it in the point column, just to give us a bit more space in our gradient column. Okay, and I'm going to do my gradient work just underneath here. So I've now got 2 points. I've got the centre, which is the one I've just found, 3, 2, and the point on the circumference 7, 5. And I'm going to use those 2 points to find the gradient of the green line. Okay, so the gradient is equal to y2 minus y1 over x2 minus x1, and we get a gradient here of 3/4. Okay, this means that the gradient of our tangent is equal to negative 4/3. Yes, we're just using that idea that the tangent is perpendicular to the radius at the point where they meet. I've now got my point that lies on the circumference, and we're not using the centre, remember, it has to be the point that lies on the circle, and we've got our gradient, and we're going to go ahead and find our equation. So we've got y minus 5 equals negative 4/3 of x minus 7, and we're going to multiply through by 3 here to get rid of those fractions. Going to break our brackets. So the same guidelines apply here as they do to all straight lines question. We have to have the brackets multiplied out and we have to have the constants collected. Doesn't matter what side you do that on. I'm going to gather them on the right hand side, and we get an answer of 3y equals negative 4x plus 43. Okay, so that's our answer to this first one here. Let me just get the highlighter out. So there's our solution. Okay. So on to a second example, same idea. Let's just firm up this approach. So we've got, I'm just going to sketch it again to start. So here's my circle, here's the centre. I'm just going to draw it exactly the same way I did before. So here's our point that lies on the circle, 1, negative 3. We're going to be finding the gradient of the radius, which is going to be perpendicular to our tangent. And first thing we need to do is find the centre. So M point equation. And I'm going to put the point here, 1, negative 3. I'm going to highlight it so that I make sure I use the right point. But I am going to do the working for the other point underneath, just so that I've got kind of equal amounts of working in each column. So what I'm looking for now is I'm looking for the centre. I'm going to get that from the equation. And again, we're just starting with 2g is equal to 2. If you didn't see where this came from in the last one, let me just highlight that. So 2g is from in front of x, and then when I got on to do, let me just finish that off. So g equals 1, and then 2f is equal to 4, and again notice that I'm taking the sign with these as well. So there's my 4, and that's my value for 2f, and so f is equal to 2. And that means my centre, which is equal to negative g, negative f, is negative 1, negative 2 this time. Okay, let's go ahead and try and find the gradient then of the green line. So the gradient is equal to y2 minus y1 over x2 minus x1. And we get this time, we're going to have negative 1 on the numerator here over positive 2. So we get negative 1/2 as the gradient of the green line, and I'm looking for the perpendicular gradient to that, which is just going to be positive 2 in this case. Okay, substituting into our equation, and again it's a straight line we're finding, so we use the line equation, not the circle equation. And we've got y plus 3 equals 2 lots of x minus 1. So y plus 3 equals 2x minus 2. And we get, again, just collecting the constant terms, y equals 2x minus 5. And there is our solution to this one. I'll just highlight the gradient that I used as well. Okay, so that's the approach. That's all you're really looking at today, just how to find the equation of a tangent. Super common exam question. I'm going to do it by finding the centre from the equation. You could be given the equation in another form, yeah, you could be given it in the x minus a all squared plus y minus b all squared equals r squared form. Extract the centre from there and use the same approach. Okay, some questions for you to try. Again, if you're on these pages are for the first edition book, which you guys are using. If some of you have got the newer edition, then the page numbers are a little bit short, and I think it'll be about 223, 224, but the exercise names are the same. Okay, have a go at the questions there, check your answers at the back, and get in touch if you've got any problems.